So just a different method of converting from decimal to binary to hecta to octal. If you remember the weight of each digit, so I'll make some lines here. I'll try to be neat. I got a cheers this morning from Brazil. Somebody watched my video. I like when they send me that cheers from Brazil, good greetings from Germany, aloha from Hawaii, whatever. So if you remember the weight of each one, this is 2 to the 0. 2 to 0, that's the 1 location. This is 2 to the 1, which is the 2. This is 2 squared, which is what? 4. This is 2 cubed, which is 8. 2 to the 4, 16. 2 to the 5, 32. 2 to the 6, 64. 128. 256. 512. 1024. 2048. I think 960496. 4096, and I give up on the last one, multiplied by 2. But that's really what the weight of each one. So when you are given a number like, can you convert 785 from base 10 to binary? Now I look at 785. I can't have a 1 here, because to have a 1 here you have to be bigger than 1024. So I'll go right here. I'll use a pencil for that so I can erase it and use that chart for more than one example. I don't want to have to redo it again and again. Where'd you go? Pencil somewhere. There's an eraser on it. There we go. Yep. So I'll put a 1 here. There's a 1. The 1 here is equivalent to 512, so I'll take 785 and subtract from it 512. And that'll be 273. 273 is bigger than 256, so is it? Yes. So I can have another 1 here. Now let's subtract 256. What's left there? 17. 17, I can put a 1 on the 16 here, minus the 16. And that leaves me with the 1. The rest of them will be what? 0. So if I don't have to write these, I'll go 1. Well, I'll put a 10 here. 1, 1, 0, 0, 0, 1, 0, that's you, 0, 0, 1. That's what 785, instead of dividing by 2 each time and spending a long time, it's 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. Yes?
How come you pick 512 as your starting point?
Yes, because that's 785. You know, I'm trying to find the biggest number.
Yeah.
That's less than 785. The biggest number is 512.
Okay.
So it can't be this one. That's I start with this. Once you put a 1 here, you subtract 512 from that number, and you look at the remainder.
Yep.
Yep. Now, if you want to convert that again, if you want to change that to octal or hexadecimal now, let's do octal. Let's take that number. Let me just write it down. 1, 1, 0, 0, 0. How many zeros? 1, 3 zeros. Then 1, then 3 zeros, it looks like it, if I'm seeing things right. Is that correct? 1, 0, 0, 1, 0, 0, 1, 1. Now, if you want to change it to octal, you go groups of 3s. Groups of 3s, 3s, 3s. 0, 0, 1. Now, with octa, you only have to look here. Remember, this is the 1, 2, 4. So 0, 0, 1, you have a 1 here. That means that's a value of 1. The next number, 0, 1, 0. 0, 1, 0. That's a 2. And the last number, 0, 0, 1, 0, 0, 1. That's a 4. I got a 1 here. You add 3, 0, or 2 more zeros to it. What's 1, 0, 0? That's a 1. And if I want to convert that, the same number, if I want to convert that to hexadecimal, I go groups of 4s now. 1, 2, 3, 4, that's 1. 1, 2, 3, 4, that's 1. 1, 1, and there'll be 0, 0 after that. So groups of 4s right there. You have a 1, 0, 0, 0. That's the first one. That's a 1. 1, 0, 0, 0. That's a 1. 1, 1, 0, 0. What's 1, 1, 0, 0? What's 1 and 2? 3. That's hexa. So we just converted that number quickly to binary, quickly to octal, quickly to hexadecimal. I'll try another one. Let me erase these because that's why I use the pencil here. Well, if I erase them, whoever looks at this example will know how because it'll be erased. I had a plan, but I didn't think it completely. I'll tell you, it makes life easy when it's nice and neat. Again, this is the 1, the 2, the 4, the 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 496, 4096. And let's say my number now, 1596. I guess since I'm going to, so I'll just put the ones and the rest will be, whatever item you use, that'll be a 0 in the previous one. And you don't have to add all, again, leading zeros are useless unless you need them, but that's what you have. 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. So I was planning on saving that, so I don't have to save it now. 1596, what's the biggest number that's less than 1596 out of these numbers? Is 1024. So I'll subtract, once you put a 1 here, take away 1024 from that number. 1596 minus 1024. That's 572. Let's look at the 572. Is 572 bigger than 512? Yes, put a 1 here. Minus the 512. What's left? 60. So nothing here, nothing here. I can't use the 64. 60 is less than 64. But I can do a 32. If you minus 32 from it, it's down to 28. 28 is bigger than 16. Minus the 16. 12. 12 is bigger than 8. Well, 8 and 4 is 12, isn't it? That's it. 12 is 8 and 4. So in binary, if you were to go to binary, this number is 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0. A little bit easier, I think, quicker. Again, change it to And by the way, you can do the reverse. If you know the zeros and ones, once you know the weight of them, like this, you can plug them in. Now I'm going to turn them to 8s and 16. Let me write that number down. 1, 1, 3 zeros. 1, 2, 3, 4 ones. And 2 zeros. That's base 2. And you want to change it to base 8. Groups of 3s. 0, 0, 1. Groups, that's what binary. 0, 0, 1. What's 0, 0, 1 in? Isn't that a 4? The next group, 1, 1, 1. 1, 1, 1. What's 1 plus 2 plus 4? 7. The next group, 0, 0, 0. 0, 0, 0. That's a 0. And the last group, 1, 1, 0. You can put a 0 here. What's 1, 1, 0? 1, 1, 0. Is that a 3? 3, 0, 7, 4. And the last one, I'll do the hexadecimal again. It was 1, 1, 0, 0, 0. 1, 1, 1, 1, 0, 0. If you go into hexa, that's groups of 4. This is 1. This is another one, 0, 1, 1, and I can add a 0 here. Let's look at the first one. Hex is 4. 0, 0, 1, 1. 1, 1, 0, 0. 8 and 4 is what? 12. That's a C. 1, 1, 0, 0. 1 and 2 are 3. 0, 1, 1, 0. 0, 1, 1, 0. 2 and 4 is what? 6. 6, 3, C. Done. I'll just post that as a separate video for converting between binary to octo and hexadecimal. Short, quick way to do it. Maybe the notes, I'll bundle them together. I'll add that to the notes as an extra sheet.